cosines. The law of sines. The law of sines is one way that we can find missing measurements of angles and sides for triangles that are non-right triangles. So we're pretty much using this for non-right triangles, or not pretty much, but this is used for non-right triangles. All right, so the two things that we're going to be looking at is law of sines and law of cosines. Today, specifically, law of sines. Law of sines is a set of proportions that is made up of an angle and its opposite side. Now, the way it's labeled is if this angle is A, its opposite side, which is this one, would be a lowercase a. The opposite side for the angle B would be a lowercase b, and the opposite side for angle C would be a little c. All right, now we're going to use this to help us keep in line or keep in our mind the appropriate order and combinations for my law of sines. Now, the way law of sines works is that it is just a set of proportions. All right, my proportions are this: side A divided by the sine of angle A should be equal to side B divided by the sine of angle B, which should be equal to side C divided by the sine of angle C. So notice that the opposite side matches up with the angle, opposite side matches up with the angle, opposite side matches up with the angle. So this is just proportion, solving a proportion, all right? It's important to realize that we have to have a matching things, okay? So like if I have side A and angle A, and then I have angle B and angle C, I can find side B, side C, which the first two examples are gonna specifically be. So looking at my first example, notice that this is 105 degrees. This is 35 degrees. I don't know if you can see that very well, but I have the opposite side of B. Now, one thing that I can do from this is that if I know two angles of a triangle, I can find the third because we know they're supposed to add up to be 180 degrees. So if this is 35 plus 105, that's 140, which means that angle A is 40 degrees. So from here, I have all three angles, and I have one of my matching sets, big B and its opposite side. So this one that I don't know would be little a, this one that I don't know would be little c, all right? So if I use A over the sine of capital A equals B over the sine of capital B equals C over the sine of capital C, I can use this to solve for my two missing sides, okay? So let's start with, I'm gonna find, let's find side C, okay? So I'm using angle B and side B, and I'm gonna find side C since I know that this is 105, okay? So when I set it up, side B7 would have to be over the sine of 35 degrees. And that is equal to side A, or actually I'm doing C. So that'd be equal to side C divided by the sine of 105 degrees. So the sine of 35 is a number, usually some sort of decimal number with a decimal, same thing with the sine of 105. So in order to solve this, I just need to multiply both sides by the sine of 105, and then C will be by itself. So when I multiply this side by the sine of 105, and I multiply this side by the sine of 105, all right, these two cancel me out, just leaving me with side C, and I find out that sine of 105 times 7 divided by the sine of 35 is approximately 11.8. All right, so when I multiplied both sides by the sine of 105, that left me with C. And when I do the sine of 105 times 7 divided by the sine of 35, it equals 11.8. So sine side C is 11.8, whatever the unit of measurement is. So if this was, let's say this is meters and this is meters. So that means when I find A in just a second, that is also going to be meters. All right, so I'm going to do the same thing for A. It's going to look almost identical. 7 over the sine of 35 equals little a that I don't know over the sine of 40. So notice this setup looks the same as this setup since I'm given the angle. So all I need to do to find the side A is to multiply both sides by the sine of 40. So I'm multiplying by the sine. Well, you can't even see that, can you? So I'm multiplying both 40s cancel out, leaving me with A, and I have the sine of 40 times 7 divided by the sine of 35. So kind of like what I did over here. And that tells me, and I find out that that is 7.84, which is A. So little a is 7.84 meters. All right, so in both these cases, when I'm solving for a missing side, all I'm really going to do is multiply both sides by the sine of the corresponding angle with the missing side. All right, so looking at example 2, it's going to be very similar to the one we just did. Once again, we're using law of sines, so it is little a over the sine of the angle A equals little b over the sine of the angle capital B equals little c over the sine of capital C. All right, so I'm just going to be solving proportions. All right, so let's start off looking at the fact that here's my corresponding parts. Angle B is 110 degrees. Side opposite of angle B, or little b, would be 21. And then I know two angles, which means I can find my third. So if this is 110 and that is 50, then that would be 160. And since I know they have to equal 180, this one has to be 20. So I know all three angles. It's going to look very similar to the one I just did. So let's start with, I'm going to find side A first. All right, so if I'm looking for side A, I'm going to use the B because that's the one I know, and then the A one. All right, so little b is 21, or the side of B, over the sine of 110 degrees equals little a that I don't know over the sine of 50. So once again, in order to solve this, I would multiply both sides by the sine of 50. I'd multiply this side by the sine of 50. So these two would divide out to be 1. And I have searching for a new laptop on the computer is like asking your old laptop to dig its own grave. All right, looking at example 3 is a little different. Notice that example 3 only has one angle, but it has two sides. I have a corresponding pair of angle C with its opposite side, and then I have the side opposite of angle B. So when I do this one, I'm still gonna do it by solving a proportion. It's just gonna be a little bit different, but once I do the first part that's a little bit different, then it becomes the same thing I did before. So once again, I'm gonna set up my proportions. I have A over the sine of angle A equals little b over the sine of angle B equals little c over the sine of capital C. All right, so when I set this up, the first thing I'm gonna solve for is angle B. Here's my matching pair, which is C over the sine of C, and then I have the opposite side B. So notice the thing I'm solving for here is angle B. All right, so this is gonna be a little bit different. So when I set this up, I have side C, which is 5.5, over the sine of 63, equals side B, which is 4.7, over the sine of part B. All right, so notice this looks a little bit different. All right, so one way that I can do this is if my proportion matches this way and my proportion matches this way, then so when I have it like this, so when I cross multiply, making a little bit more room. So when I cross multiply, I end up doing the sine of B times 5.5. So I end up with 5.5 times the sine of B equals 4.7 times the sine of 63. All right, so there's one last thing to get the sine of B by itself. I would divide both sides by 50 or 5.5, divide this side by 5.5, those cancel. And so now I have the sine of B equals 4.7 times the sine of 63 divided by 5.5. So I can type this in my calculator and I find out that it is approximately 7.61. So the sine of B is approximately 7.61. I need to do some operation to get B by itself. This is where inverse trig comes into play. So I do the inverse sine of my 7.61, and that should equal my angle B. So once I do this, I find out that the angle B is approximately 49.55 degrees. All right, so there is my angle B. All right, so when I come back and look at my triangle from just a second ago, I have angle B is 49.55. Now that I know this angle, I have two of my three angles. I can find my third. So if this is 63 plus 49,